And let us continue with the general problem solving techniques or tools which are used in AI. The next one is knowledge engineering and reasoning. We know that a state space will be consisting of many states, beginning with an initial state and ending with a goal state. For improving the efficiency of problem solving, what we have to do is to reduce the number of operations to be performed. In a state space, we will be using the operations on some states for generating new states. So if we reduce the number of states in the state space, automatically the number of operations to be performed will also get reduced. We know that we cannot remove the initial state or the goal state. The only possibility is to remove the intermediate states. Why do we have these intermediate states? Suppose there is an initial state and some goal state. We will be having a path from initial state to the goal state, and in between there may be many number of states available. For example, suppose we take there are 3 such states in between the goal state and the initial state. Let it be X, Y and Z. So from the initial state we will be applying some rules on the initial state to produce the state X, and on X we will be applying some rules for producing the state Y, and on Y we will be applying some rules to get into Z, and from Z we can reach goal. Suppose we want to remove, we cannot remove the initial state or the goal state. Suppose we are removing the state Y. Then what happens? From initial state we will be reaching X, and from X we have to reach where? Z, because Y is not available. So for reaching Z, we have to perform those operations that can take us to the state Z. From Z we can directly go to the goal state. So if we have the knowledge of the state Z at X, we don't need that intermediate state of Y. So we have to increase the knowledge at a particular state so that the next state can be removed. So that is the technique used in knowledge engineering. We will be concreting the knowledge base with additional knowledge so that we will be able to get into the required state without intermediate states. Thus, we can improve the efficiency of the algorithm or problem solving methodology. For that, many tools are being used, many procedures are being followed, and one among these is the planning. It is done to find out the techniques to accomplish the desired state. As I told you, we have to reach the desired state from the current state without the intermediate state between the current state and the desired state. For that, we should have additional knowledges. So in applications such as robotics and navigation, automated planning is extensively used. So planning is a required entity for improving the efficiency of problem solving in knowledge engineering. Then we have also seen what a knowledge acquisition means. It involves mainly 4 steps. One is the creation of new forms of knowledge on the basis of existing knowledge base. We will be creating new knowledge from the available knowledge. We know that knowledge is always have the tendency to change, so it is having a dynamic nature. So for handling these knowledges, we should have a dynamic data structure. Then we have to acquire knowledge from the surrounding. So we'll be having knowledge from the surrounding, then from the knowledge base. Since we are gathering knowledge from the surrounding, it is subject to changes. So we have to use dynamic data structure, and we have to refine these existing knowledge with all these things. We have to update the existing knowledge. So this is the process involved in knowledge acquisition. Then logic programming is another one. We know that the knowledge can be represented in the form of binary statements, also called as propositions, and such propositions can be handled by some languages which are designed for that purpose, especially programming language like Prolog. We have seen that before. So logic programming also plays an important role in knowledge engineering and reasoning. Human beings are having the ability to reason or learn from uncertainty. So the system also should perform in that way. For that we will be using soft computing. It is an emerging approach to computing. So soft computing, by definition we can say that it is a computing model evolved to solve non-linear issues. So it helps to solve issues where human intelligence is required to solve the problem. Such problems should be met or dealt with the soft computing techniques. It is particularly attached to human intelligence. We will be using probabilistic models, fuzzy logics, then neural networks, some algorithms like belief calculus. All these things, genetic algorithms, all these things constitute the soft computing technology. So in AI, to simulate the properties of human intelligence, we will be using fuzzy logic, artificial neural nets. All these things are associated with living beings, and that techniques are being used for solving non-linear issues. So this is another area in knowledge engineering and reasoning. Here, fuzzy logic can be defined as a method of reasoning that resembles human intelligence or human reasoning power. It is used when we have an uncertain situation. The approach of FL imitates, FL means fuzzy logic, imitates the way of decision making in human that involves all intermediate possibilities between digital values yes or no. Either we can have yes value or 1 or a no value 0. Anything that comes in between this yes and no can be decided by human being intelligence. For that we will be using fuzzy logic. The fuzzy logic works on the levels of possibilities of inputs. We can have many number of inputs which are only probable values. So the inputs are probables, it is based on probability, and the output should be definite. To reach a predefined output, we can use different inputs. That is based on intelligence of human being. So such situation is handled by fuzzy logic. Then we have already seen that what artificial neural nets means, because the neural networking system of human beings are simulated by the use of electrical networks. They are called as artificial neural nets. Genetic algorithm, we are coming to that topic shortly. Then we have a belief calculus. Also, the belief calculus definition states that it is a quantitative representation of evidence perceived by human. It is the quantitative representation of evidence perceived by human, and it is used in uncertain reasoning. So this is also a property exhibited by human being. Inductive logic programming we have seen in the last class. So these are the soft computing areas that support knowledge engineering and reasoning. It is especially used when we have uncertainty in the values available. Then the next one is management of imprecision and uncertainty. Suppose we are having some values and we are not sure whether the values are correct or not. Then we have a doubt in using those data for problem solving or for finding the solution of a problem. So this situation arises in two cases: when relevant data is not available, relevant data which is required for the solution of a problem or a state at present, then we have uncertainty. Then another one is data is available, but the source from where the data we got is not authenticated. Then also we may have doubt in using that data for that state. So in both these cases we have uncertainty. Then we use some techniques for reasoning under such uncertain situation where data is not available or relevant data is not available or the authenticity of the source of the data is not accurate. Then we are having different techniques for approaching that situation. They are stochastic reasoning, then fuzzy reasoning, another one is belief network models. Stochastic means a probabilistic. In this technique, we have a transition from one given state to a number of succeeding states. From a given state, we will be having transition to many number of states. And the sum of the probabilities of these transition is always 1. When we add up the probabilities of these generated states, we will get always 1. That is stochastic reasoning. Then we have fuzzy reasoning. In fuzzy reasoning, we have already told that in fuzzy logic we will be having different types of probable values for the inputs, and we have only a definite value for the output. And in between, when we have different input values, we can apply some rules like if else rules, if then rules, and based on the intelligence we can perform or reach to the output. So with each of the input we will be having some reasoning area or some values, and these values can be, there will be many values because there are probable number of inputs, many inputs, and we have only one output. And with respect to each of the input, we can assign some values which is based on some if then rules, and these values are called as membership values. So the inputs have corresponding membership values, and these values will be in the range 0 to 1. When these values are added, it will be always 1 or more than 1. So that is the calculation which is being used in fuzzy reasoning. We can have many probable inputs, and we will be having only one definite output, and with each of the input we can assign or find a space with respect to the rules assigned. Some logical rules will be applied to these inputs, and with some calculation, intelligence calculation, we can assign some values for each of the inputs, and these values will be in the range 0 to 1. When we add up all these values, it will be always be equal to 1 or more than 1. So that is fuzzy reasoning, and these values are called as membership values. With the stochastic and fuzzy values, we can update the facts which is embedded in the belief network. We should reach to an equilibrium state. With these values, stochastic reasoning probabilistic values and fuzzy reasoning values, it should be applied to the facts available in the belief network model, and we should reach to an equilibrium state. Once we reach that state, then there will be no change in the belief network. That is the idea. So using the values of stochastic reasoning and fuzzy reasoning, we can make the facts available to an equilibrium state, and after reaching that equilibrium state, there will not be any changes in the belief network. Then we have neural networks. It is used to identify patterns in input. We are having many inputs, and we will be finding some pattern in that input so that we can generate new input without actually having that input. If we get a pattern, then we should not have that input, because this pattern will take into a new input, and this pattern is used for implementing function approximation. The approximation function has the following features. It is smaller than the true function, naturally, because we are reducing the number of inputs. If there are 5 inputs, and the 6th one can be generated with the use of these 5 inputs pattern. Suppose we say that after one input we should do the second input, then the third input, then the fourth input, and we should have at least 9 inputs in that way. And if we have a pattern, after 5 we can directly go to 9 using that pattern. So we have eliminated the input 6, 7, 8 from the 9. So it becomes smaller than the actual function, because the number of inputs have been reduced. And it is utilized for inputs for which the function is unknown. Actually, the true function is called as the known function. When it is not the true function, we can say that the function is unknown, because we are approximating some values, or approximating the function to some degrees. Then we have reinforcement learning. Here each of the state is evaluated, and it makes a choice between the following 2 things. It explores a new thing, it can explore a new thing, or it can exploit the previous or current knowledge. By using these methods, the evaluation of each state is being done. Exploration of new things or exploitation of present thing. We have already made a small discussion on global ontology with an example of a book, because a book can have different premises, and based on the premises, the definition of the book may change from person to person. Building large knowledge-based system is complicated task because the knowledge comes from multiple sources, and these knowledge in different formats must be integrated. The sources may not have the same division of the world because each of the knowledge is representing an entity in the world. So sources may not have the same division of the world. Knowledge comes from different fields having their own distinctive terminology and divides the world according to their own needs. Suppose a person, we are having two persons, A and B, and A will define some object in his way and B defines some other object or the same object in his way. Both of these may not match always. So that is a problem which relates to global ontology. The systems evolve over time and it is difficult to anticipate all future distinctions that should be made. Moreover, the system or knowledge about an object may change from time to time. So we cannot have a definite or accurate, precise definition for identifying that object. The same object will be having different definition or description on different angles. The knowledge-based design must choose what individuals and relationship to represent. For representing an entity, we should have a candidate. The knowledge-based designer should select the right individual and the correct relationship for representation of an entity in the world. The world is not divided into individuals. It is something done by intelligent agents to understand the world. And different people involved in a knowledge-based system should agree on this division of the world. So there should be some standardization in the division of entity or in defining the entity in the world. It is difficult to remember our own notation meaning and also to discover what someone else's notation means. So if there is no standard, we will be assigning our own meaning to some object and it will be difficult to recall what we have defined for an object. Again, some other objects or definition will be, we should capture that definition from them also. So this lead to the two aspects. Given a symbol used in the computer, we have to determine what it means. Then given a concept in someone's mind, determine what symbol they should use. These two aspects comes into consideration. That is, determining whether the concept has been used before and if it has, discovering what notation has been used for it. So whenever we have a concept, we should check whether it has been made before and if so, we have to collect the notation in what way it has been used. We have seen that there are languages like OWL, Web Ontology Language for World Wide Web. It defines some classes and properties with a fixed interpretation. So we will be dividing or regrouping these objects in the world into different categories and we will be assigning some meanings according to their class or properties with some interpretation. So anybody can build ontology, but it should have semantic interoperability. If there are many ontologies, they should be comparable or interoperable. To share and communicate knowledge, common vocabulary and agreed on meaning for that vocabulary is required. That means we should have a standard for making this meaningful words or objects, or assigning meaning to an object. A conceptualization is a mapping between symbols used in the computer. We can have some concept and map these concepts into some symbols. And that is called as the vocabulary of the ontology. This should depict the individuals and relations in the world. It provides a particular abstraction of the world and notation for that abstraction. Only some things are being considered, that is meant by abstraction, and we should have some notation for that considered abstraction. In philosophy, ontology is the study of what exists, and in AI, ontology is a specification of the meaning of symbols in an information system. So we'll be storing some symbols in information system, and it should have some meaning, and that meaning is called as ontology in artificial intelligence. Typically, it specifies what type of individuals will be modeled and specifies what properties will be used, and it gives some axioms that restricts the use of that vocabulary. By the example, you will reach to the conclusion of this sentence.